Thank you all for joining us today, and I apologize for the technical glitch, and I hope we can get it going now. And the topic that, as you may have seen from the invitation, is about our new product, which is Biotronic Top 3, that is focused on pathogen control and performance. And before going into the product, I would like to give some brief introduction on the issues that we are facing and how this product could be a better option. And when we look at the feed microbial content, this is from literature review, about 56% of animal protein, 36% of vegetable proteins, and also 14 out of 30 farms that were tested, and 57% of feed delivery vehicles. Again, this is a bit dated data, but again, these are tested positive for pathogen presence, so it seems like they're ubiquitous. But one of the key management practices that we do is to overcome this pathogen challenge is thermal treatment, pelletization. And here in the table, you can see on the left column is the temperature in Celsius, and then we have Enterobacteriaceae count as a biomarker for salmonella contamination, and then the salmonella percentage of salmonella calculated based on the Enterobacteriaceae count. And as the temperature goes up, the percentage of salmonella contamination in the feed goes down. And this is published data. But on the right side, you can see different locations in the feed mill, a mixer, pellet mill, cooler, and loadout. And one key point that I would like to draw your attention is the loadout. The salmonella contamination went down from the mixer after the pellet mill and after the cooler, but the loadout, it came back again to 5%. So, which indicates that the potential recontamination from the point it comes out of the pellet mill. And this chart kind of gives us more detail on how the pathogen load increases after the feed comes out of the pellet mill. The first bar is after mixer, where you have high bacterial count, and then the expander, pellet press, and then the cooler. But then when it hits the truck, and within a day, it comes back to the same level of count as the count that was in the mixer. So again, this is also published data, but it just gives you an idea on how the recontamination is a real thing, and the pelleting process, even though we think that it might help us, it doesn't really help us in the long run, particularly when we keep the feed for at least a day, 24 hours. It just doesn't really do a lot of help. So in this scenario, one of the key options are to look at the pH factor, and managing the pH would potentially help us in overcoming this pathogen load. And the red arrow shows 5 pH, and the different colored bars are E. coli, different strains of E. coli, and Salmonella, Clostridium, and Campylobacter. And as you can see, from pH 5 and above, the bacterial growth is really high, and as the pH goes down below 5, the growth is very, very minimal, and it's almost less than 0.2 OD optical density. So gives an idea, the pH plays a key role in maintaining the bacterial growth. And organic acids have been long used to maintain proper pH and to lower the pH and maintain the gut health. And the major functions are reduce pH and buffer capacity. They reduce the pathogens in feed and gastrointestinal tract. They prevent recontamination of feed, and they improve performance. Overall, they improve feed hygiene and gastrointestinal health. Out of the organic acids, the acids that we have selected are formic, acidic, and propionic acid. And just want to go over briefly on why we selected on those. These two graphs can show you on Salmonella typhimurium and Salmonella enteritidis, and the different acids, how they work against these two pathogens. And here you can see formic acid on the red bar and acetic acid on the navy indigo, and then propionic acid on kind of like a teal color. All these three acids have really high efficacy in blocking or inhibiting Salmonella typhimurium compared to other acids such as malic, benzoic, butyric, citric, fumaric, lactic, and tartaric acid that were tested. The same scenario you can see on the right-hand side with formic, acidic, and propionic. they were the kind of like outstanding assets in overcoming this growth challenge from these two pathogens. Looking at E. coli also gives us the same kind of image where formic acidic and propionic inhibited the growth of both strains of E. coli that we tested. So this gives an impression why we selected those acids and how efficient they are. The other component is a phytochemical that we have in this product. The component is cinnamaldehyde. It is an effective antimicrobial and a bacteriostatic, helps to balance the gut microbiota, improves feed intake and growth promotion. So again, overall improves the gastrointestinal health and performance. The key point here I would like to highlight is the bacteriostatic property of cinnamaldehyde. As most of you may know, bacteriostatic is stopping the growth of bacteria, while bactericidal is killing the bacteria, completely eliminating it from the system. And cinnamaldehyde is bacteriostatic, means that it blocks the growth of bacteria. How does it block the growth of bacteria? So here, this is kind of like a little bit complex cartoon, but on the left top, you can see the FITC protein, and the GTP-dependent polymerization into filaments causes it kind of to replicate. And the simple story here is the cell divides into two. So there is a ring that forms in the middle, and the rings kind of gets more constricted, and it splits the bacteria into two. So formation of this ring and the effect of this ring, the Z ring, what we call the assembly, and how this ring helps the bacteria to replicate into another or two bacteria is a key thing. And what cinnamaldehyde does is it blocks the FITC protein movement in the cell. So basically, it blocks the assembly of Z ring. So you'll have the Z ring in there, but it may not be assembled properly. So you have depletion of FITC profilaments and the dissipation of Z rings, and reduces the frequency of Z ring formation. What does that mean is the bacteria stays in the same shape. It kind of, you have like half-formed Z ring, but it's not really being efficient. So the bacteria is not replicated. It's still the same one organism instead of two. So it inhibits cell division of pathogenic bacteria. And this image could help us to explain better. The one labeled A on the left side, here you can see the square. On the top left corner, you can see almost a neon lighted thing. That's the Z ring. That's the bacteria you're seeing. That's the size of the bacteria. Whereas on the other side, you can see a bacteria which is so elongated on the image B on the top left, and it's got 4 bright spots. So what that indicates is that these were the Z ring, and the bacteria never divided fully, so the bacteria got elongated. And instead of being 4 different organisms, you can see just one bacteria. And so it's basically the bacterial growth is inhibited. The same amount of bacterial count is being maintained. So the difference between image A and B are the size of the bacteria. And in the B, you can see all like elongated shape, and with a lot of Z rings in there. So this is the key role of cinnamaldehyde in blocking the activity or efficacy of Z ring in helping to divide the bacteria into 2 organisms. So the selective action is against pathogenic bacteria. It spares beneficial bacteria. Looking at the synergism, because that's again another key aspect of cinnamaldehyde. Excuse me, when you think of adding cinnamaldehyde with an organic acid combination, because it's not that easy to add a phytochemical to an organic acid blend, but to maintain the efficacy of organic acid, because the acids, again, based on their pK value, they have antimicrobial property, they lower the pH, and they have bactericidal capabilities. So you have one that works on bactericidal and one works on bacteriostatic. You got to have really a good compatibility between these two to work together. As we know, a lot of products carry phytogenic compounds with organic acids, but the efficacy of them together is a big question. So here in this in vitro trial, you can see the growth inhibition on the y-axis. On the x-axis, the first one is the acid blend, the acidic, formic, and propionic acid blend. And then we tested 7 different phytochemicals. And the 5 bars you're seeing, the first one is Salmonella enteritis, then Typhimurium, then 2 different E. coli strains in green, and then a Clostridium in blue. Here you can see the first one is basically the efficacy of the 3-acid blend in inhibiting the growth of the different pathogens. But the second one, and from everything else, from phytochemical 1 to 7, all these bars are percentage of the first one. So to be clear, here you can see that close to 80% of Clostridium growth was inhibited by this acid blend. Phytochemical 1 inhibited 100% of the acid blend. So that means the phytochemical 1 did not affect the Clostridium inhibition efficacy of acid blend. So 100% means 80%. It just let it stay the same. Whereas when it comes to this E. coli, it's only 50%. So that indicates the acid blend was its efficacy was at 30%. Adding the phytochemical reduced that efficacy to 15%. I guess this is clear. It's a very complicated way in how this slide is set up, but just kind of to give an idea, all of these bars are percentage of the first 5 bars, respective percentage. Like if you go to phytochemical 6, where Salmonella enteritis is only 10% with the acid blend. So the real acid blend's number is somewhere close to 50% or above 50%. So that means adding phytochemical 6, the acid blend loses its efficacy and it brings it back only 10%. 10% of this 50% is only 5%. So this bar would be here if we add the phytochemical 6. So looking at cinnamaldehyde, which was the phytochemical 2 that we tested, you can see it did not really affect the acid blend's efficacy. It was almost 98%, 99% of the acid blend, and even it increased the efficacy of acid blend over 100%. It's about 110%, meaning it's about 88% of acid blend's efficacy. So it has more additive effect than negative effect adding cinnamaldehyde with this acid. So that's how we ended up with this unique combination. Now, there is another key component to this product which we think is quite unique in helping our efficacy of both the acid and the cinnamaldehyde. And this image on the right kind of explains that why this permeabilizing complex is a key in this product. This is a cell that is basically for explanatory purposes. It's divided into 2. On the left-hand side, we have the conventional product that is with an acid and a phytochemical that tries to enter into the bacterial cell. And it takes more time to work through by themselves because they have to break the bacterial cell wall to let all these different acid and phytochemical components enter into the cell. On the other hand, we have this permeabilizing complex, which is like a wrecking ball, breaks the wall of the bacteria and lets every other component to go into the cell wall and do its action. So the permeabilizing complex is the key in the sense it punches a hole in the wall of bacteria, pathogenic bacteria, quickly and easily so that the acid and phytochemical can exert their efficacy. Here you can look at the permeabilizing complex and how it works. The top images are control, and then you have EDTA and PAI, different types of permeabilizing complexes. EDTA is something that we use not on a daily basis, but when we collect blood sample and for different purposes in the labs, we use EDTA, and that's sort of a permeabilizing complex. So on the control, you have compact and smooth surface, no rupture on the cell surface. While EDTA, which has the permeabilizing qualities, it causes rough and damaged surface on the cells, while PAI causes flocculation and aggregation of these cells. So that's the different actions of different permeabilizing complex, and depending on their source, they can also differ in their efficacy. So overall, they destabilize the outer membrane of gram-negative bacteria. They increase the sensitization to antimicrobial, and then they increase the lethal injury to bacteria. Here is one assay that shows how the permeabilizing complex, or the PC, damages the bacterial cell wall. It's an NPN uptake, a phenylnaphthalamine uptake assay. We use a fluorescent probe for that, and the uptake of NPN by bacterial membrane is manifested as fluorescence, and it indicates the damage in gram-negative bacteria. So in simple term, we mix the PC with the fluorescence dye and then apply that on the bacteria. And the moment the permeabilizing complex punches the hole, the dye gets into the bacterial cell. So when we read that under fluorescence, we'll see how much of bacteria is glittering, basically, and getting the fluorescence. Then that much bacteria has been affected by the PC. That means the cell walls are compromised by the PC. So we looked at here, you can see at pH 7.2, this is how much just the pH causes damage to the bacterial cell. And this is EDTA, as we saw in the previous slide. EDTA is, of course, one of the permeabilizing complex, but efficacy varies. And 2 different strains were tested, E. coli and Salmonella typhimurium. And you can see from the right, PC 0.001%, 0.002%, and 3%. And you can see for both E. coli and Salmonella at 0.003%, you have NPN uptake at its highest, indicating that the NPN, which is the fluorescence dye, was able to get into the cell wall into the inside of the bacteria through the hole that on the cell wall was caused by the PC. So this shows the efficacy of PC in how it can damage the bacterial cell wall. This is on the growth inhibition test on the PC and how it affected with and without the presence of PC on the antimicrobial mixture, which is the organic acid and cinnamaldehyde. So basically, the gray bars show that we have only the acid blend, the formic, acidic, and propionic, and then the cinnamaldehyde. The green bars are with permeabilizing complex, and then the acid blend and cinnamaldehyde. So the acid blend and cinnamaldehyde are present in both, but one with permeabilizing and the gray one is without permeabilizing. And you can see common pathogenic strains and their efficacy, how they were improved. Like here, the E. coli O128, the efficacy of the acid and cinnamaldehyde wasn't that effective because they weren't able to penetrate and get into the cell wall of this bacteria. But when we add the PZ, it hit 100%. The inhibition was 100%. So that gives us a clear idea that not just the acid and adding a phytochemical is enough. We have to help them to get into the cell, through the cell wall into the bacteria. And the PC is the unique component that helps us to achieve that objective. Here it's the same graph, but only highlighted with the key organisms, pathogenic organisms, the Salmonella enteritidis, typhimurium, E. coli O55, and O128. And you can see the significant improvement in the increase of growth inhibition after adding the PC. This is individual organism and over time how they performed. Excuse me. You can see the gray lines are control, and the orange lines or yellow lines they are the acid mix, and the red lines are the PC, and then the purple lines are the acid mix and the PC. So the acid mix also contained the cinnamaldehyde. So as you can see, the permeabilizing complex just punched the hole in the wall, so the bacteria was damaged, but still they were able to replicate, and they just started growing. Here, just the acid blend, the orange bars, for about 10 hours, they were able to manage the bacterial growth. But afterwards, the bacteria started to replicate because the bacteria were not killed, so they started to replicate. But addition of the permeabilizing complex with the acid mix, you can see that it continuously maintained for 4 days, for 2 days. There was no bacterial growth when it comes to Salmonella typhimurium. And the same thing for E. coli, same situation. So overall, the permeabilizing complex is a unique component that can enhance the efficacy of the acid mix and the cinnamaldehyde that is in the product. And that's what makes this product to stand apart from the others, how it helps in overcoming the challenge of getting the acid mix into the cell of bacteria. Finally, the carrier that we used here is worksite, which is a phyllosilicate, and the unique property of this sequential release medium, what we call it, is because it's highly thermal treated. It gets treated up to 800 degrees Celsius, so it expands when gets treated thermally. So it carries the components, all three components, the PC, the acid blend, and the cinnamaldehyde in it. So overall, what it does is it takes them through the gut and releases in a sequential manner instead of releasing all at once in one place. So this is a very efficient carrier in getting these components reached to different parts of the gut. So overall, we have this combination of top 3 combination of organic acids, phytochemical, and permeabilizing complex administered on a sequential release medium. Now, I would like to kind of give you some overview on the trials. Here's a nursery trial. We did with the 60 weaned piglets. They were weaned at 28 days. There was a standard diet and top 3 at 1 kilogram, which is about 2 pounds per ton. 3 replicate pens per group and 10 pigs per pen, 42 days after weaning. And here you can see the trial results. They change, the number of animals and the starting body weight were same. The final body weight was about 1 kilogram higher in the top 3 group, which is about 2 pounds higher. Feed intake was 50 grams higher. Daily weight gain was 24 grams higher. FCR was 1 point up. So overall, just for going for 42 days, we did see 1 point improvement in FCR, but overall the final body weight gain was about 2 pounds up. The second trial, where we looked at the same design, but 56 days. And here you can see there were some significant differences in the final body weight, about 2 kilos, which is about 4 pounds higher. So increasing from 6 weeks to 8 weeks, just 2 more weeks, we get almost double the response. And the FCR was about 5 points down. So overall the efficiency went up and daily weight gain was also significant here. And so it indicates that the more we use this product in the nursery and into the grow finish phase, the better the body weight gain and the performance is. And this is another one, a commercial trial where we did with just the same trial design, but for 56 days. And here also we did see the same response of 4-point FCR down for 56 days. And then this is 96 weaned piglets against a common antibiotic combination of colistin plus CTC and 56 days. And so the first column is the negative control. The second column is positive control, which is the negative control plus CTC and colistin. The third column is the top 3. And then the fourth column is the negative control versus top 3. And the last column is the antibiotic versus top 3. Overall, when we compare that against the antibiotic, you have 2-point FCR down and about 157 gram feed intake and 90 grams increased weight gain, which was the same as when we compare against the negative control. But the FCR was a little bit up compared to the negative control. But in the absence of antibiotic, top 3 improved the FCR overall and also did not compromise the final body weight gain, increased over 5 kilograms in both cases on the final body weight gain, which is about 10 pounds increase in body weight gain. Then this is a finisher trial for 98 days, 2 groups again, control and Biotronic top 3. And you can see, of course, the FCR went up, but the final body weight also went up for 6 kilograms. The duration was the same, 98 days, so the pigs were stayed in the basically considered to be treated for the same time in the finisher. So for treating for 96 days, the final body weight gain increase and the daily weight gain increase was significantly higher, about 6 kilograms compared to the control group, although the feed intake went up, which increased the FCR. But here I think the key is to have increased final body weight gain. The final trial is about 48 sows that were tested on this, and it was the trial went for 2 reproduction cycles, gestation and lactation, and the lactation phase was 21 days, 24 sows per group. And so the first row is the control first cycle, the top 3 first cycle, then the control second cycle, top 3 second cycle, then the average of both. The first column is live born, and the birth weight kilogram per piglet, and the litter birth weight, and stillborn percent, mortality, and mortality numbers per liter. And overall, you can see the birth weight was significantly increased with the addition of top 3. Kilogram per piglet was higher significantly, and actually the increase was we were able to see that in the first cycle, but in the second cycle it was significantly increased. And again, stillborn were reduced about 3% or 2.5%. No, actually, it's about 3.7%. Mortality was reduced about again 2% plus, and mortality in numbers were reduced about 0.3. And on the weaned piglets, again, the sow milk yield was increased about half a kilogram more per day, which is a significant increase. And the average daily gain was increased about 14 grams per pig per day in the nursery. So that's a huge increase in terms of body weight gain every day when we think of it. And overall, the weaning weight of these piglets that were sent to the nursery was about 5.6 to 5.8, about 200 grams more per piglet. So that kind of gives us an idea on the efficacy of this product, and I'm sure you'd be interested to have more information. And to summarize that, Biotronic Top 3 has the unique formulation containing organic acid blend, phytogenic compound, permeabilizing complex, administered in a sequential release medium. And overall, the results that we have seen have increased nursery piglets, average daily gain, feed intake, overall performance in nursery as well as in finishing pigs, and also in sows, increased litter birth weight, lower stillbirth and mortality, and increased average daily gain and weaning weight. So, as I said, I'm sure you'd like to see more data in your system, and we are really open to that, to work with you. And if you have any other question, we can discuss questions now, as well as we'll have our team reaching out to you pretty soon and to give you all the required information that you may need going forward. Amy, can you unmute everyone?
Muted.
Noemi, you there?
Yes.
Unmuted.
I think there is. Okay, there's a question. Is the trial information available to attendees? Yes, absolutely. We can provide the trial information, and we have actually more trials than what we have seen today, and we can very well pass information, and our guys will reach out to you.
How long has this product been available worldwide?
This product's been available worldwide as it was launched in 2010, so it's been 6 years. And there's another question. What was the health status of the sows used in the sow trial? We did not do any specific testing on these sows, and they were on a normal commercial farm where we blocked them and used them. So there was no challenge or anything. It was like normal production system. You can type in your questions. It seems to be unmuting everyone causes this audio interference. Do you have data with poultry? Yes, absolutely. We have data with poultry, but right now we are launching this product only for swine. We are working to get the poultry version. It's same, but just trying to get it through the FDA compliance. But definitely we can send you the poultry information. I'll reach out to you. On the nursery trials, did you measure if these effects lasted out to the market? No, these trials were done only in the nursery, and we did do a couple of finisher trials, and they did, as I showed here, they did come out good. But those pigs were not treated at the nursery. But we would be we'd be open to look into that since it requires more trials, and we do have trial data from other regions, and I'll see if I can get any information from other regions. But so far from the trials that we conducted towards this product registration, it's we didn't look at the same that's feeding in the nursery and then looking the performance throughout the end of the production cycle. Any studies from wean to finish or grow finish? Yes, absolutely. As I said, we have a couple of trials done. That one I presented for the 98-day grow finish trial, and the first trial or the second trial that I presented was actually going into the wean to grow phase, but not to the finishing phase. But as I said for the previous question, I'll reach out to other regions to see if they had done anything, because since they have been having this product for a few more years than us, we are going to have this product. We already have the product in ground now, but the 6-year period that we have been having this product should definitely have some more data available in other regions. Any other question? Okay, one more. On the South trials, was this fed in lactation or a combination of lactation and gestation? It was a combination of lactation and gestation. So the sows were fed throughout the whole cycle, for both cycles actually. So the product was fed through gestation and then lactation. Okay, I got a couple more questions coming up now. Um, any studies with variable rate or is 1 kilogram per metric ton is sole recommendation? Well, our basic recommendation is 1 kilogram per metric ton or 2 pounds per short ton. But the variable rate is not really required for this product because of the formulation. Unless we have very severe challenges that we recommend to go at 2 kilogram per ton and then lower it down to 1 kilogram per ton once the challenge is rectified. But again, that being said, I wouldn't put this as a treatment product. It is a more preventive. So if we know that there's a particular bond where we have more challenges, then we'd start with 2 kilograms or 4 pounds, and then we can lower it down to 2 as soon as the problem goes away, and then continue at the same 1 kilogram per metric ton. The next question is, what is the cost per ton of feed? I think our sales team can reach out to you to provide that information. I think they have that worked out at this point. So I'll make a note and I'll ask them to reach out. But at this point, it should be under $4 per kilogram. Any more question? Well, if not, We're always available. I'm available, and our team is available. Our sales team would be reaching out to all individually to give you the information, any other information that you may require. And we're always available to take your calls and give you the information. And again, thank you all for your interest today and joining us. And we very much appreciate your time and spending that with us and listening to our new product. And again, as I said, you can always reach out to us for any other question. Thank you all. Have a great rest of the day. Thank you.